Good morning. Welcome back to class. As we progress through these things, you'll be able to send me comments on what you think has gone good, what you think has gone bad, any ways we can improve the videos or make them better in any way, and we can make the best product we can come up with together. So welcome back to class. I'd like to start off with chapter 30, light emissions. And again, as always, we start off with our atom. Neutrons and protons in the middle, electrons in the shells around the outside. As energy is imported into this atom, it excites these electrons from one shell to the next shell. From your vocabulary words, the excitation is the adding of energy to an atom to cause the electrons to move to a different shell level, a different shell height, based on the amplitude and energy involved in the electron. As it moves from one shell to the next shell and to the next shell, and if enough energy is added to that particular atom, the electron leaves the atom entirely and is emitted as what we call a photon, a massless particle that carries the energy out to the world in the form of light or heat or any other form of the electromagnetic spectrum, depending on how big it is, the amplitude, how long our waves are, the distance from the crest to the crest, the wavelength, and the frequency that these wavelengths slam into you. These three variables, and only these three variables, determine all forms of energy, all forms of wave transmission in the world. These electrons are only capable of existing at these discrete shells, these special shells that have a certain size to them. As these electrons are moving, as with everything, moving electrons must travel in wave motion. So these electrons, as they're spinning around, they carve out their waves. And the next shell spins around and carves out its waves. These waves take up a certain amount of space, a certain amount of territory, making sure they don't bump into the territory of the next shell down. And as we move from one shell to another, they have to have a specific amount of energy to occupy that size. If an electron had occupied a space somewhere in the middle of these electrons, the waves for its territory would have bumped into the other electrons, forcing them, ejecting them from the atom, destroying that atom as they move around. And since the electrons are moving at relatively the speed of light on a really, really small scale, the amount of distance that they travel around the time, the number of rotations, if a collision were capable of happening, it would have happened already, a long time ago. So the only electrons still capable of existing in these specific shells, these quanta of electricity. Quanta is a measurement, is an amount of energy required to have a specific amplitude of the wave for these electrons. Now, as these electrons are excited out, they give off their light, their photons. However, if they don't have enough energy to get kicked out of the atom entirely, they drop back down, move from an outer shell all the way back down to their normal unexcited state. This is called de-excitation, another one of your vocabulary words. And when it goes down, it releases that energy as well, causing it to become free energy and go all the way around and add energy to another atom somewhere else and start this process all over again. The exact same amount of energy that causes the excitation and is released by the de-excitation, nothing is ever lost. Our conservation laws require higher, that all of this energy remain constant. Nothing is ever destroyed in the universe because it's just always got to be the same. The world loves to be in balance. And these different lights, motions, based on our three variables, the wavelength, the amplitude, and the frequency, determine all of the different types of electromagnetic waves. All of the transmissions of energy in light are one of these forms. It's always this wave. It's always the same wave, just varied on those three principles. And that takes care of every type of wave you can possibly have. As we're moving across, I'd like to talk about a few of the forms of emission of light. How are we creating light in the world? We've talked a lot about an incandescent bulb, just your normal light bulb. How the electrons enter the light bulb and go up the wire and hit that filament, which is in fact a semiconductor. Will only allow a certain amount of that energy to go through, a certain amplitude of those electron waves to go through that filament. The rest, it's kicking out. Most of it in the form of heat, but also some light. These lights going out, lighting up your room, but that heat is also being pushed out. We don't use that heat very often, unless we're talking about a Betty Crocker oven and making some brownies. Most of what we're looking for is the light. So this is a very inefficient form of light. Moving along into the fluorescent lights, we're just using light. A light of a different portion, possibly infrared, possibly ultraviolet, usually ultraviolet light, are being added to this filament. So enough of this energy goes up and excites these electrons to a higher level. And when they drop out, the de-excitation, the release of the energy, is released as visible light. It drops down in the spectrum, but becomes that light that we're looking for. We don't waste all of this energy in forms of heat. So it's much more efficient. It takes better usage of all the energy that is imported into the atoms. Another one is phosphorescence. This is glowing things. A number of different materials, different elements, have the capability of holding on to that energy. As the electrons are excited to higher levels, they get stuck up there. Just like your stickers of the stars on your roof in your bedroom. They continue to glow. As you're laying in bed, you shine a light on the stars until they're glowing, and you turn the light off really fast and see what you see. So they glow for a while. Now, eventually, those electrons will de-excite out, and they won't have that excess energy that causes them to glow. I hope this has been informative, and we'll continue on again tomorrow. Have a good day.